Okay, last time we talked a little bit about how to export data, and I believe by reading through the material, you now can understand what ASCII is about. I don't know, some of you had a problem last time to do the export. We created an array of A equals 1, 2, 3, 4, 5, 6. Then we said just type in save my data.txt A, then ASCII. The whole point of this, you will get a folder called my data.txt. So instead of having a MATLAB to look at it, because many .am files always need a MATLAB. But when you create a .txt in this case, you can open it in a notepad or anything else. So you have access at the numbers and the data in a similar way. You would be able to see the data looking like this for you. Then you'll be able to load back the data into your MATLAB as needed. So we said A to equal 1, 2, 3, 4, 5, 6. Make a space just in case. Close it, then you got your A. Then what else we said in our slides? Save my data. So save, I can call it my data.txt. Then that's for A. Then you say ASCII, capital or small. ASCII, anything else? No. Now doing that, you should be able to see on your computer a mydata.txt that you can open it. Either you can open it in MATLAB or you can open it on your computer. Similar to what we can see here. You see my data.txt. So you can open it as a txt file. It's a way to sometimes export your data if you want to use it for report purposes or whatever going on in your program. Then you can load, either you write my data.txt or you just load my data.txt, which we're going to do here. .txt. So you just loaded your data to the side over here. Double click on it. You can look at it, see all the numbers, and you have it on your desktop or wherever you save it as my data.txt in the ASCII format. Again, that's how it looked like. You should have my data.txt. Should be able to save or load your data. You can look at them in MATLAB. They will be as normal numbers, but you created a separate file where you can open it without a MATLAB, because all the .m software or script that you save need MATLAB to open, while in this case you exported the data to be able to access it within any other software within your PC or your MacBook. Now today we will talk about logical vectors. We will discuss about discontinuous graphs, avoiding infinity whenever you have infinity in your solutions or script, how to find a way to roll around it and still be able to graph your data as needed. We will talk a little bit about logical operators. We touched base on those before, but we're going to talk more about it in this time, how to implement it in many ways. And subscripting, we talked about it before, but we will have it with logical vectors, and we'll talk about logical functions if you have enough time. Now, the objectives for this chapter, obviously it's a new chapter, we need to understand the logical operators in a better way, and we will try to see the logical vectors and how to use them effectively in many applications, and we discuss about logical functions. Now, for the logic vectors, you have your MATLAB in front of you. Let's have the statement r equals 1, semicolon. Then now we are trying to have some logic. R less or equal to 0.5 without a semicolon. Your command window should look like this, and your answer should be telling you logical in blue underlined 0. It means he processed a logical operation, which we can call as a logical vector in this case, and he said logical 0. Whenever in MATLAB you see logical, most likely it should be either 0 or 1. Logical 0 means false, like your logical operation or logical statement that you wrote is false. That's the output of it. If it's true, he's going to show you 1. So 0 for false and 1 for true, and MATLAB differentiates 0 from the number 0, writing the word logical. Now you have r equal, mathematically, don't just code it, look at it mathematically. R equals 1, so the value of r is 1. Now 1 less or equal to 0.5. Is that true? That's false. So you got back 0. Now you can write in your MATLAB, if you want to write 2 greater or equal to 5, he's going to give you 0. 2 greater or equal to 2, he's going to give you 1. You can try that out. Now for the same script that you wrote, r equal 1, semicolon, then r less or equal 0.5, you can change it to r greater or equal to 0.5. Obviously, that's mathematically true, and that's logically for MATLAB, that's true. So you got back the return of value 1. Let's say r equals vector 1 colon 5 semicolon. R less or equal 3, how does your command window look like? So you got an array from 1 to 5. Now you are questioning in a logical vector. R less or equal 3, then you get the answer 1 by 5, so 1 row, 5 columns, logical array. So he asked the logic of each component in that array, if it's true or false. You guys are following that? Now he will go to each component of the array and ask, is that what you ask here is true? So if all of these are the values of r, is every single value of r less or equal to 3? 1, is it less or equal to 3? Should I say true or false? True. I'm writing the word T. I mean the letter T. Now 2, less or equal to 3, still true, right? 3, less or equal to 3, that's true. Now 4, less or equal to 3, false. 5, less or equal to 3, that's false. Now, in MATLAB, true and false. True is 1, false is 0. Those are logical expressions. You can't say true multiplied by 2. It will never mean anything, you know? It's a logical expression. Now, changing those from true and false in MATLAB language, you can say 1, 1, 1, 0, 0. Just keep that in mind. Maybe you get a table, who knows, in the exam, then I'm just telling you, change that into logical representation. Maybe, I'm just assuming here. We will talk about the truth table as well, where how things go together, true and true, true or false, false or false. And now if you can change r less or equal 3 into r equal 4, then you should get back 0, 0, 1, I mean 0, 0, 0, 1, 0. And you can try more expressions if you wish. Now, another topic, discontinuous graphs. Probably those of you who took integration in your high school, do you guys take limits in high school? Limits? No? Well, the thing is, integration in the simplest form, if you have a graph, then you're gonna know what's the area of this graph. You split it into small segments. Those segments have certain width, you know? Then you combine all of those segments together to get the final value of that area, if you're talking about the area under the curve. That's integration. Now, limits is the previous step of integration. So before that, if you have a graph, let's say you have a graph looking like this, then he stop, then he continue here. That's called discontinuous graph. Usually this graph will finish either in a solid point, like you have x and y here for the point, or he can finish in a hollow point, like it's not a well-defined point, and all of that details. Now, if you want to take the limit for this portion of the graph, so this kind of graph is called discontinuous graph. It's not a continuous graph, basically. So you take limit 1 for this graph, limit 2 for this graph, and maybe eventually you'll take the total limit, probably. Like if this is from 0 to 1, this is from 3 to 5, take the limit 0 approaching to 1, and the limit 3 approaching to 5, and so on. So here we have y of x equals sine x over the range 0 to 3 pi. So the first function for y of x is sine of x, and the second value is 0. Sine of x, so you're telling the program, or you want to tell the program in a code, y of x equals the function sine of x whenever sine of x greater than 0, and it is 0 whenever sine of x value is less or equal to 0. Now we want to do that over the range of 0 to 3 pi. How are we going to do that script-wise? We can say x equals 0, column pi divided by 20, column 3 pi. So 0 to 3 pi with increment of pi over 20. Now we say y equals sine of x, then semicolon. Then we say plot xy. Don't write the third line. So plot xy, he's going to give you a certain plot that's probably different than what you see here. Go ahead and try that, see what you get. So if you do this and you plot, see what's going to happen. Add to path. So you get this sinusoidal graph if you plot it this way. Now, I want to say exclude the negative numbers. Like whenever the graph goes to the negative area, cut it off so that you will see graph similar to what's in the slide. What I will do, I will say y equals y multiplied by each component in y in case it has more than one component. Multiply y by any logical value when y greater than 0. Like whenever the logical expression is true, like 1, 1, 1, go ahead and take that. Anything less than 0, exclude it. Take it out of the equation. So he's going to include only the numbers which are in the positive area. And that's how you deal with or create a discontinuous graph in case you need it. Go ahead and run it. So as you can see, we cut off all the negative values below 0. So you can see the graph starting from 0 in the y-axis, going all the way to 1. As simple as that. So keep that in mind, how to use logical functions or logical arrays to get rid of negative values. Then I use this kind of scripting, which is like the value equals the value multiplied by each value with the logic whenever that number is greater than 0. Now, avoiding division by 0, many times while you're working in MATLAB, you will find yourself getting back in the command line NaN, like I believe it's called not assigned number. There's many ways people define that abbreviation. I think it's not assigned number is easier for me to remember than NaN. So suppose we want to plot the graph of sine x divided by x for the range minus 4 pi to 4 pi. Now first thing we do, we say x equals minus 4 pi with an increment of pi divided by 20 all the way to 4 pi, semicolon. But if you try y after that equals sine x dot divided by x, means divide sine x by all values of x in case there's more than one value. What I realized, the author was trying to show you how dividing by 0 will give you a NaN numbers in the command line. But the reality is, for some reason, the MATLAB 2022, as we mentioned, the author was using MATLAB 2018. In 2022, I think they automatically do what the author is suggesting to do. But go ahead and do it. You will know what I'm talking about. So you should get a NaN. You see here, x equal NaN. That's what you should get. But trying that myself, it didn't do that. It's like MATLAB recognized dividing by 0 and handled that automatically with the new version. Because before you get NaN, dividing by 0, the thing is what we do, we have something called logical vector that replaced the 0 with EPS. I believe there's a definition for EPS over here. So it's standing for the precision of floating numbers. What it does, it depends on the type floating number that you're using. If the number you type, the number type that you type is double, then EPS would be 2 to the power of minus 52. But if it's single, it will be 2 to the power of minus 23, and so on. So in this case, you see y equals 0. When you had the EPS of y, it gave you, instead of 0, 4.9 e to the power of minus 324. It's like instead of getting a 0, you get a number very close to 0. It's too close to 0, but it's not exactly 0, so you avoid 0 by doing that. That's using the function EPS that we see here. So if you continue in your script, or maybe we can go together, but as I told you, it's not really working very well because the new MATLAB that you guys are using and I'm using are already taking those into consideration, and he can plot. So ideally, when you run this program, y equals sine x divided by x, because some of those values of x are zeros. So he should give you a nan. Like when you see the list of numbers, you should see nan. So that means it's unidentified operation because you're dividing by 0. But in this case, MATLAB executed. You see, MATLAB executed anyway. He shouldn't. He should just give you some numbers are NaN, and he's not able to identify what are those. So what we're supposed to do based on the author, add a line before the plot, x equals x plus, between parentheses, x equals 0 multiplied by EPS. It means whenever you see the value of x as 0, give me a number close enough to 0 but not exactly 0. So still your graph look the same, but your numbers are not exactly 0. And that's how you avoid the 0. X equal x plus, then we say x equals 0. Whenever you see x equals 0, multiply it by EPS. It means make it close to 0, closest value to 0, but it's not exactly 0, so that we'll not get back an error message and so on. See, he plotted either way, but he shouldn't. Like in the older MATLAB, he don't do that. But now he by default multiplied by EPS, so that he will avoid dividing by 0. You can see here we added x equal x plus x equal 0 by EPS. That will adjust the 0 value of x to EPS. Now, avoiding infinity is another problem. Sometimes you get back a value of infinity or too large value. Like when you plot, you need numbers to be close together. You see the sinusoidal curve that you had, there's a big hump. If that hump was hitting to 1, right? What if that hump was hitting to 100? Then you're gonna see a big hump. Maybe it looked like a triangle, but the small little waves, you'll not see it anymore because it's too small compared to the hump. Like the hump is going to 1,000, while those are going to 0.2, the small humps, then you don't see them. Sometimes you need to see the graph looking homogeneous and looking, making sense, and all numbers are close together. We have that problem here, which we call it avoid infinity. Plot tan of x over the range minus 3 pi divided by 2 to 3 pi divided by 2. Now, of course, again, we identify. You can try to type that. X equals minus 3 divided by 2 multiplied by pi, column, increment pi over 100, column 3 divided by 2 multiplied by pi, semicolon. Then y equals tan of x, plot x and y. In this case, you should see this graph, but this is a problem for us because the small ones, if you zoom into them, they are not supposed to look like this. Like those two humps shouldn't look like this. But because those are too big, then you're not able to see what's the pattern of those two. So what we're going to do, we're going to cut these two big ones and keep those two. But by adding a statement that will help us avoiding very big numbers and get all the numbers close together. He doesn't add numbers, but he deletes all the outliers, the big numbers that are messing up with your plot. Now let's try to add y to avoid those big humps and get something make sense. Y equals y dot multiplied by the absolute value of y less than 1 multiplied by E10. So those will remove the big numbers and keep the small numbers that you should see but you couldn't see in the first graph in between those big numbers. So that kind of statement or approach is used to avoid the big numbers in case you're trying to plot something more focusing on the smaller numbers, or numbers are varying from each other. There's 4 numbers close together, like 2, 3, 4, but there's 100 and 500 on the sides. So that's kind of trick you use to avoid big numbers all the way to infinity. Avoiding infinity, you see, you didn't have this at first. So when you run the program, you can see those are too big to let those little ones show up in terms of pattern. Now, let's bring back this int was commented out, not part of the program. So y dot multiplied by absolute of y less than 1 E10, run it, then you get the graph as it should look like for you without involving the big numbers. And that's how you avoid big numbers or infinity. Now, counting random numbers. I want you to write a code to count random numbers generated by the function rand1,7 semicolon, knowing that all the random numbers that will be generated will have the value between 0 and 1. And assume that your code that your friend gave you as a cheat sheet, you put it home, then a baby sleep on that code. You can't touch the baby. If you wake up, it's a big deal. So you gotta rewrite it, find a way how to solve it. You don't want to be the baby in the exam, though. So, of course, the function is random. In case any of you don't remember that, it's rand. So rand 1,7 semicolon. If you don't want to see it in command line, without semicolon if you want to see the numbers. It's always a good idea in your stage to see what's going on. Those numbers all are between, so the value of the numbers is between 0 and 1, as maybe you saw already in your command line, right? Now, of course, you can count them in the command line, how many numbers, but I need to do that through a code. Show me how many, well, I'm going to make it easier for you. Show me how many numbers are less than 0.5 and how many numbers are greater or equal to 0.5, and show me the total number of random numbers. First thing we do, I'm not going to solve it. I'm waiting you to tell me r equals those values. So encapsulate them in a variable so you can play with that variable. So you said r equal rand 1 to 7. Maybe you can see it at the hand of the baby up there. R equal rand 1,7 semicolon or without, whatever you want. Then now I want to test for something. You got to test for something, which this something. Whenever it's under 0.5, do 1, 2, 3. Whenever greater or equal to 0.5, do 1, 2, 3. Eventually, whatever you got here as a number and here as a number, have it for me in the total. And remember, we're talking about logical vectors. So you are trying to use some logic right away without if statement, nothing, in the simplest form possible. So now if I say, like you can see kind of letter S, S equals, what if we try S equals, we are guessing here, open parentheses, R less than 0.5. So S will have all the numbers less than 0.5, right? Then we do another one, maybe call it P equals, open parentheses, R greater or equal to 0.5. So now the P have whatever greater than 0.5, and combine them together and display the result. See what happens. Drop the baby or keep him. Again, guys, we sometimes walk you through some steps, let you stumble a little bit, struggle a little bit, because you need to know what's going on. So drop the baby. What we had here, so your S that you had, that's okay, but instead of equal R less than 0.5, just add the word sum. So instead of showing you 1, 1, 0, 0, 1, he's going to show you how many ones over there. Then you can easily have total, then you can easily have, you let him display for you the final total, or you write a message or whatever you want. So those ones and zeros you saw, he was testing R. Whenever R less than 0.5, if the number for the R less than 0.5, he was giving you 1. Whenever it's more than 0.5, vice versa. If less than 0.5, that's true, that's 1. If greater, then he give you 0. So how many ones? He's going to count it using the sum, like how many ones or how many numbers less than 0.5 making this statement true. Kind of tricky, but if you think about it, that's fine. Now, if you want to do that without logical vectors, you were easily saying S equals sum of R less than 0.5. Then he tell you, oh, there's three numbers which are qualified to follow your logic, R less than 0.5. Now, to do it in the old style, forget about the tick-tock here. Those just to tell you how long it took time. It's just more longer even for the processor to do it this way than your way. Your way is the efficient way that you did, but you can go with the old way with the if statement. You can say A equals 0, B equals 0 for n equals 1 to 5,000. Let's assume he has 5,000 random numbers. Now, the R equal rand for those 5,000 cycles. If R greater or equal to 0.5, then A would equal A plus 1. A equal A plus 1 is a counter, so he count every time the if statement will be true. Else B equal B plus 1, so he's going to count whenever the if statement is wrong. So whenever R greater or equal to 0.5, count 1, 2, 3, 4, so on. Else count it as it's less than 0.5, you know. That's kind of a counter. Then end the if statement, end the for loop, and display for me less than 0.5, then change the number to strings for A and show it to me. Display for me time, like how long it took the MATLAB to solve it, that kind of thing. I'm not sure if I have it. Counting random numbers, yeah, I do. By the way, note on the side how to comment a group of lines. You can have the percentage sign, open kind of that fancy parentheses, I don't know what you call it. Then you close it this way, then you're going to comment out anything in between. That's one trick to keep in mind, very useful, instead of having commenting of every line. Or you can go to commenting over here, just highlight what you want and comment them out. Like I can highlight these and comment them out over here. Or I can do this way, which I love more. So I can delete it, they come back to the surface. Now he said tick and tock, then that has nothing to do with tick-tock. Okay, so you see, less than 0.5, he had 2,545 of the generated numbers, assuming he have to do that 5,000 times. Time took him 0.034 of a second. Now, logical operators, we touched on that before a little bit. So we know this operation means not, and this is and, this is or. How to get this sign? Shift, or I mean command if you're on Mac, and that sign of / above the enter or the return. That's that. And the truth table. Now assume you have the first table having false, false, true, true. F for false, T for true. This is a truth table telling you what to do with operation when they are in and or with not. So now we have here false, false, true, true. For the second line, we have false, true, false, true. Now, if we have the sign not, then the true will be false and the false will be true. So for the not, there's true, true, false, false. Assuming he processed it for the first column, the false became true and the true became false. That's what not do. Now, if I have column 1 and column 2, like false and false, what I'm going to get? I'm going to get always false. False and true, I'm going to get as well false. True and false, I'm going to get false. True and true, I'm going to get true. For the and sign, whenever there is false involved, the result always false. So he's doing or between column 1 and column 2. False or false, going to give you false. False or true, going to give you true. True or false, going to give you true. True or true, going to give you true. So if you say 1 or 1, you say 1 or 0, 0 or 1, 0 or 0, see what happens. Whenever in or you have 1, whenever you have true, you got to get true. That's how it works. Now, for the XOR, which we're not going to, I believe we're not going to use it in this course, but for the XOR, if you have false and false, you're going to get false. False and true, you're going to get true. True and false, true XOR false, going to give you true. True XOR true, going to give you false. Now, if you said not 0 and 0, what he going to give you? He going to give you false, which is 0 in your command line. While if you say not between parentheses 0 and 0, that's going to give you 1 or true. What happened here? It's about priorities, right? Do we have the priorities? Yes, we do. Remember the priorities? So the logical operations, which is, I believe, the not is one of them, is higher in priority than and or. So always MATLAB gonna process the logical operations before. It's still and or is logical operation, but I mean greater than, less than, and not gonna process first, then and will process next. So here what happened? Not 0 will give him 1, 1 and 0 will give you 0, right? That's what he did. He go from left to right, priority for the not. Now when you put parentheses, priority for parentheses, 0 and 0, what's the value for 0 and 0? 0. Not 0 will be 1. MATLAB see true as 1, false as 0. Now there is some equations into true and false when you use and, when you use or. So this is or, and this is and, this one. That's called the truth table. You need to remember 0 and 1 will be 0. 1 and 0 will be 0. 0 and 0 will be 0. 1 and 1 will be 1. What does that mean? It means here false, 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 and this is true. You have more to try here. You can, on your own time, try those. Each line represent like one problem. See the priorities and how things work together. I support you to go, put 1 and 0, 0 and 2, 0 and 1, 0 and 0, 0 or 1, and so on. Try on your own, see what happens. Priorities, we know that. Now we have a problem, 2 greater than 1 and 0. So we have logical operations. We want to know priority. Priority to greater than or to and. We can see the priority is to greater or less than, which is number 7. Then comes the and. So he gonna process this first, then he process the and. Now, if you put in MATLAB 2 greater than 1, what he gonna give you? Go ahead and put it in command line. 2 greater than 1 only. 2 greater than 1 will give you 1, which means it's true. It's not giving you a number, it's telling you it's true, true statement. Now, 1 and 0. Put 1 and 0, see what happens. 1 and 0 gonna give you 0, right? Because what we said there, you gotta remember that whenever there's 0 with and, you're gonna get 0. That's it. That's just telling you true and false. But you need to know the priorities. There is no, here all are indicating, like 2 greater than 1. Is 2 as a number greater than 1? Now you say, yes, true. Now true represented as 1. Forget about the numbers now. He's just indicating as true. Now true and false gonna give you false, which is 0. Suppose r has the value 0.5. Now you say 0 less than r less than 1. Now this would be evaluated in MATLAB as 0. But you know that 0.5 is greater than 0 and less than 1. Why he said false? So if you put in your MATLAB r equal 0.5, in MATLAB, if you say to him r equal 0.5, then you tell him 0 less than r less than, what was it, 1, 1. Now, mathematically, 0.5 is greater than 0, less than 1. He should give me back, I'm waiting him to tell me true or false. He should give me true because mathematically, r as a 0.5 is between the value of 0 and 1. It should be true. When I hit enter, he tell me, no, that's false. What happened here, it's like the operation paradox. So you need to know how MATLAB works. The thing is, he said, what he did MATLAB, he go from left to right. 0 less than 0.5, that's true. He's gonna give you 1. Then you say 1 less than 1, no, that's false. So he gave you false, even though he should give you true. That's what happened in the background. Now, if you want to be sure about this kind of representation, that's called a code trap. So you need to put parentheses 0 less than r and r less than 1. So you tell him that's what I want to test exactly. Then in this case, he's going to give you the right result. So I can say here 0 less than r and r is less than 1. In this case, you will not confuse him because he gets confused even himself between numbers and logics many times. That gave you 1 as it should be. So when you have an array 1, 2, 0, -4, and 0, you say not, you're going to change all the 1s into 0s and all the 0s into 1s. Try not just whatever inside parentheses, not 120 minus 40. First, I want to say 120 without the not, then minus 4, then 0. Alone, what you got? You got these. Now, if I give him the not, if you give him not, what you're going to get? Now you get 0, 0, 1, 0, 1. So whenever any value not equal to 0, it became 0. Any value 0 became 1 because not flips everything. But in this case, he's not going to flip the 2 into 4. He assumed the 2 greater than, it's 1 equal to 1 or higher. So he assumed it 1, flip it other than 1, it's going to be 0. That's what he did here. What if we did the not, open parentheses, of the not of, what is it, 120? Yeah, 120 minus 4 and 0. Okay, close that. What happens? He's going to give you 1, 1, 0, 1, 0. What he did? He flipped your not. Like here when you had the not. So he had the logic 0, 0, 1, 0, 1. It's like false, false, true, false, true. When you give him another not, he's going to flip it again. The zeros will be ones and the ones will be zeros. It means the false will be true and the true will be false. So it's going to give you 1, 1, 0, 1, 0. You can see the 0 is 1 and the 1 is 0. So let's try to solve this by hand. If A equals minus 1, 0, 3 and B equals 0, 3, 1, he say not A. So all the values of A will be not, like what we did with the first one. Then he say A and B, what's going to happen? A or B, what's going to happen? Forget the XOR, I don't want it from you now. A greater than 0 and B greater than 0. All the way down, see what you get.